Hello everyone, welcome to the GATE NPTEL lecture course. Today we are going to solve the question number 35 from GATE 2016 exam. In this question, it was given that a particle of mass m equals to 0.1 kg is initially at rest at the origin. It is start moving with uniform acceleration at time t equals to 0. What is the action of the particle in joules second at time t equals to 2 seconds? So we have to calculate what is the action of the particle, and we know that action is given by Lagrangian into dt, where time is varies from t equals initial, which is 0 second, to t final, which is 2 seconds. So we have to calculate this integral. And to calculate the Lagrangian, we must know what is the kinetic energy and potential energy. So to calculate that, we are given the mass at 0.1 kg. It is given that it is initially at rest at origin, that is at x equals to 0, particle velocity is 0, and at time t equals to 0, its acceleration is 10 meter per second square. So the action of the particle S, which is given by t initial to t final L into dt, L is the Lagrangian, which is kinetic energy minus potential energy. And since it's a one-dimensional motion, so kinetic energy is given by 1 by 2 mx dot square. We are given the force m, mass which is 0.1 kg, and acceleration which is 10 meter per second square. So from that multiplications, force is given by 1 Newton. And since force is equals to minus del V by del x, it is equals to 1 Newton, and on integrating, we get the potential energy V, which is equals to minus x. So our Lagrangian, which is kinetic energy minus potential energy. Now we know that del L by del x dot, which is equals to momentum, which is mx dot, and from all the Lagrangian equations of motion, we get d by dt del L by del x dot minus del L by del x equals to 0. Del L by del x is equals to 1. So we put d by dt, that will give mx double dot minus 1 equals to 0. And by putting the value of m equals to 0.1 kg, x double dot will become 10. Now if we integrate it with respect to time t, we get the expression for x dot, which is 10t plus c1. And we are given the boundary condition that at time t equals to 0, its velocity v is 0, since it will start with rest. So from by putting these values, the constant c1 will become 0. So our x dot is 10t. Now we again integrate it with respect to time t, and we will get the expressions for x, which is a function of t, and it will become 5t square plus c2. Now it is given that at time t equals to 0, the particle is at rest, that is x is 0. So by putting this value in this expression, we get the constant c2 equals to 0. So our x is 5t square, our x dot is 10t. And now we will put into our Lagrangian expression 1 by 2 m x dot square, which is 10t whole square plus x. So this is our Lagrangian. So our actions, which is 0 to 2 L into dt, will become 0 to 2 10t square dt. And now when we integrate it, and by putting the limit, this is our value for the action, 26.66. So the correct answer here is 26.66. Thank you.